Okay, earlier in the videos, we talked about how you got this equation, how you wrote this equation. So you're going to need to watch the other videos to figure out where the negative 20 cosine pi 6x plus 25 came from. Once you get to the calculator steps, though, for C and D, you can type it into your equation. So I have negative 20 cosine of pi 6, so pi divided by 6. Make sure you use pi and not 3.14. And then x, and then we close that parenthesis, plus 25. Now when you graph it, you're not going to see a very good graph because our window is wrong. So your window is based on what you had for your scale. So when you look at your graph, the x-axis, we need to go from 0 to 24 for this problem. For the y minimum, we need to be able to see to about 50. You know, I think it was 45. But if I graph this window, then I can see 2 complete revolutions of the Ferris wheel. Now, this question we talked about before, 1 minute and 45 seconds, is really asking for f of 1.75. That's what we looked at before. And we have to figure out what that equals. So the way that I've been showing people how to do it with their calculator is you press trace and you find the value of the function at 1.75, and this is going to give you the ordered pair. So this answer is 12.824. Okay, so this equals 12.824. But we talked about before how you needed to write that in a sentence. Okay, so before, the sentence could go something like, at 1 minute and 45 seconds, the person will be 12.824 feet off the ground. So make sure that you have your x variable with units, your y variable with units, and you answer the question. Okay, now when it says show your work, okay, as long as you've used function notation, okay, which we did up here, f of t is function notation, this part right there is showing your work. Okay, if you have y equals, then you can't just use function notation for your question. Okay, for part D, okay, you're going to go back to your graph, and it says during the first 12 minutes. So that tells you to change your window, okay, to 0 to 12, because that is the first revolution of the graph. So the first 12 minutes. When was the person at least 25 feet off of the ground? And we talked about this in the last video that I was working out on paper. There's our constraint. And we need to figure out when these two values happen. To do that, you go to second calc number 5. You can just press number 5. Enter, enter, and then you go to the intersection point that you're looking for. Okay? And so this happens at 3.000. So I'm going to say the first one is 3.000 minutes. Okay? The second one, you do the same thing, second calc, number 5, enter, enter. But now you have to go to the second intersection that you're looking for. And you can guess a value. You can type in whatever you think it might be, 10 maybe. And I'm going to come over here, and I'm going to press enter. And it says 9. Okay, so what that means is 3 minutes and 9 minutes. And so what that means, if I look at my calculator here, that between 3 minutes and 9 minutes, the person will be at least 25 feet off of the ground. And that's what you write for your sentence. So we would say between 3 minutes and 9 minutes, the person is at least 25 feet off the ground. And so that would be my answer for part C and D with the work shown on the calculator.